In this video we're going to learn about the definition of sine, cosine, and tangent. You can see the word here on the screen, Sohcahtoa. That's going to be our way that we remember the different definitions. There's some other phrases that you can use, but this is what I use when I'm trying to teach this, and what I think is the easiest way to do it. So let's start out by drawing a right triangle. We'll draw a right triangle here. So we have a right triangle, and we're going to call this angle here theta. Okay, so we're going to define sine, cosine, and tangent based on the different sides of this right triangle in respect to theta. So let's first put some little helper words here. So the angle on the opposite side, or sorry, not the angle, the side opposite of this angle theta, we're going to call the opposite side. So we'll label that one as opposite. Now this side next to the angle, this side right here, we're going to call that the adjacent side. So let's mark that as adjacent. Okay, and then the long side of the right triangle, as we know from other videos, is called the hypotenuse. So we'll label that one the hypotenuse. Alright, so we have our right triangle now. We have it labeled like we want. So now we're going to use this made up word here to help us with the definitions of the different trigonometric functions, sine, cosine, and tangent. Okay, so now we're ready to do our definition for sine, cosine, and tangent. So what we're going to look at is the first three letters of this word, S-O-H. What does that mean? So the S stands for sine. So we're going to have the sine of theta. What does that equal? OH. So we have an O here, opposite, H hypotenuse. So that equals the opposite over the hypotenuse. Then we look at the next three letters, the C-A-H. So the C stands for cosine of theta, C-O-S, cosine of theta. And then that's equal to AH, adjacent, over hypotenuse. And then lastly we'll look at the last three letters of the made up word, T-O-A. So the tangent, or tan, of theta is going to equal OA, opposite, over adjacent. So there's our three definitions. Now a couple of things to note before we look at some actual examples of this. First of all, if you think about it, the sine and cosine are always going to be less than or equal to 1. Why is that? Well, in a right triangle, the two sides that aren't the hypotenuse are always smaller than the hypotenuse. So you're always going to have a fraction that has a smaller number on top because the hypotenuse is always bigger. So these two fractions are always going to be less than or equal to 1. The tangent, it can be other numbers, because if you think about it, the opposite side could be much larger than the adjacent, or vice versa. So it could be a much larger number, or it could be a number close to 0 as well. So the other thing to think about is if we have a triangle, let's just draw a big triangle here. Okay, so this triangle has angle theta here, and so the sine of theta, as we said here, is opposite over hypotenuse. Well, what happens if this angle theta gets smaller? So so this green triangle here, so it has an angle, we'll call this angle x. Well, angle x is smaller than angle theta, and also the opposite side of x, here noted in green, is also smaller than the opposite side of theta that we started with. So as our angle is shrinking, our opposite side is also shrinking. You know, if we do that again and make it even smaller, so this purple angle here, we'll call that Z. So now Z, the opposite side, is this big compared to the other two angles. So what you can see in this graphic is that as the angle gets smaller and smaller, the opposite side is also getting smaller. So what does that tell us? That tells us that as that angle gets closer to 0, the sine is also getting closer to 0 because the opposite side, which is the top of our numerator, is getting closer to 0. So likewise for the cosine, you see these hypotenuses, hypotenuse, whatever the plural of that is. I'm marking these with with the arrows here. So as our angle gets smaller, our hypotenuse gets closer and closer in size to this adjacent side of the angle. So this is the adjacent side. So as this gets closer and closer to 0, that hypotenuse is getting closer and closer to the same size as the adjacent. So the cosine then is getting closer and closer to 1 as the angle is getting closer and closer to 0. Okay, enough of that. So let's look at some examples. So if you remember back in the previous video we did, so we had two special triangles. We had one right triangle with two angles. One angle is 30, the other angle is 60, and we called that a 30, 60, 90 triangle. So then the other triangle we had was a right triangle where each of the non-right angles were 45 degrees. And we called that a 45 triangle. So we had some definitions about the sides of each of these triangles. So for the 30, 60, 90, the small side was x, the hypotenuse was 2x, and the other side was the x square root of 3. And then for the 45 triangle, both sides were x, and the hypotenuse was x square root of 2. So then we can use these definitions to find what the sine and cosine are of 30, 60, and 45 using these values. So let's look at the 30, 60, 90 first. So what is the sine of 30 degrees? Well, it's the opposite over hypotenuse, so x over 2x, and then canceling our x's out, we get 1/2. Likewise, the cosine of 30, that equals adjacent over hypotenuse, so x times the square root of 3 over 2x. Crossing out our x's again, we get the square root of 3 over 2. And then finally the tangent of 30. So we have the tan of 30, and that equals opposite over adjacent, right? So opposite is x, adjacent is x times the square root of 3. So if we cross out the x's, we'll get 1 over the square root of 3. Now our math teachers don't want us to leave a radical in the denominator of a fraction, so we're going to multiply this times the square root of 3 over the square root of 3. We can do that because that's equal to 1, and then we'll get the square root of 3 over 3. Okay, so let's look at the 45, 90 triangle. So here we can do the sine of 45. Well, that's opposite over hypotenuse. So that's x over x square root of 2 equals 1 over the square root of 2. Just like below, we want to get that all radical off of the denominator. So we'll do this, and we'll get square root of 2 over 2. And the cosine is going to be the same thing because the adjacent side is the exact size as the opposite side. So the same exact thing. So then last, the tangent of 45. Well, that's easy because the tangent of 45 is just opposite over adjacent, and that equals x over x equals 1. Okay, so we've defined the sine, cosine, and tangent as they relate to the angles in a right triangle. We looked at a couple of examples, and now we'll use this information in the next video to define the unit circle.